I already got more buoyancy problems, right? So now we've got this rock under the water, right? And we've got 40.4 newtons. And then, of course, there's also the buoyant force acting on it, right? And then, of course, gravity is acting down. And we know that that's 5.34 times 9.81. All right, so let's see. Well, let's figure this out, right? Because I think if we figure out the buoyant force, we ought to be able to figure this out, right? Okay, so here's what we know. We know that the buoyant force plus 40.4 equals 5.34 times 9.81. This, by the way, is the weight of the rock, in case you forgot everything we did last year. Okay, times 9.81, and then I'm simply going to subtract 40.4. And I'm going to get that the buoyant force is 11.9854. That's got to be worth something, don't you think? And then, of course, we know the buoyant force is it's the density of the fluid. And we know that. Hey, this is looking good. Volume of the rock, we don't know that. G, we do know. And we know the buoyant. So we can figure out the volume. We know its mass. We got its density. Okay, let's go for it. Okay, so 11.9854 equals the density of fluid, so 1,008 times the volume of the rock, which we're about to figure out, times 9.81. Okay, so I'm going to divide this force by 1,008 and divide also by 9.81. And I get that the volume is a piddling 0.001. Remember, we're dealing here with cubic meters, so our cubic meter would be momentous, right? Okay, so now we're almost there, right? So our density is mass over volume is 5.34 divided by a very small number. Right, so I'm going to go 5.34 divided by the answer I just got, 4405.7. And now we got this great dilemma, what do we do? I just said 4406 because I didn't want people saying, oh, you rounded that to 4410. But rounded to proper sig figs, it would be 4410. I just don't like sig figs very much. Oh, hey, I just got a text. All right.